Welcome back. So today we've been talking about a bunch of different things, but mostly software development security. And we're going to jump into a couple of concepts that usually people struggle with. And so what I'd like to do is jump into it and talk a little bit about relational databases. So with a typical database, there's a lot of interesting things that you can do. There's a lot of interesting things that we can do. And if you've never played around with a database before, usually what we talk about is these things called data sets. Are usually groupings of like data. And with a database, usually see, in Visio, a database drawn as a cylinder. And then underneath it, it can have n number of these things that are called tables. So each database can have n number of tables, meaning as many tables as you want. And one thing is certain, that you need to have what is typically called an identity seed, quote unquote, or a lot of times you'll hear people say key. And these primary keys are a way for us to essentially do what's called have a unique value, but also allows us to, on that unique value, to index. And the reason why you quote unquote index something in a database is because you index a primary key. It helps increase the performance or speed for lookups. And this primary key usually is numeric, or it is something that is unique enough that you don't have to use it more than one time. And so in this first example that they give in the book here, this is probably one of the better ones that they do. And for purposes is, and in for relationship or relational databases, the primary key is usually not only unique, but it's there for what is called referential integrity. So basically, when you refer to that primary key, you can utilize that primary key in any table. Okay, so let's say that my SSN is the primary key. So I put the SSN in this table right here. That's going to be my primary key. And for the tables, let's say we have a people, I think I gave this example the other day. Places. N would be the primary key in the people table. Well, we might actually, put that SSN in all three tables. So then we don't need to have other characteristics that are associated with it in all three tables. We have maybe, in the people table here, we have first name, last name, and the SSN. In the places you've been to. So how would that look? Well, you may have one entry in the first people table for a person. So let's say, in the people table here, let me just draw this out. Let me get a different color here. Erase that. And I need more space here. I will not be confined, or constrained, I should say. I'm going to use the pen, and let's do that below. So in my database here, I might have a peoples table, kind of like the Rock, the peoples, whatever he calls himself. So SSN, first name, and last name. And, my SSN might be 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. First name might be Ben, and then this would be the people table. Over in my places table here, I might have, SSN and place. So in the people's table, this would be a 1-to-1. So I have one value for that person in the people's table. There's only one value in there. So over here in this places table, I would have a 1-to-n over here. So what does that mean? That means that I can do 1, 2, 3, 4, 5, 6, 7, 8, 9 over here. And then let's just say San Diego. And then I have 1, 2, 3, 4, 5, 7, 8, 9 over here. And I have Huntsville. Then I have one Tampa. Right? And so that 1-to-n means I can have a one-to-many relationship. But essentially, this is again a database here. If I want to, what I can do is I can write a SQL statement that will join these two tables together. And essentially, the joining part, the way that we join them together, key. In this case, the SSN. So I have a 1-to-1 relationship over here. And then that 1-to-1, now I can link and join on the primary key, which is in this case an SSN. And so that immediately says that, hey, in the people table, it's related to the group of records that are in the places table, and it's joined. We're going to based on the SSN. And so when we write a SQL statement, which would be a structured query language, I don't know why it's saying that. Yeah, plenty of storage space. We would do select all from people. And then we would do this thing that's called a join, tables together, interjoin places, and then we would tell it on SSN. And that's pseudocode there. I'm not actually going to write the real SQL statement. This is just for brevity purposes. But it'd be very similar to that. So we join the two on the SSN. And so essentially this one-to-one would come back. We would see all the records in this, and then we would see all the records in this as well. So we would see, since we join these two together, we have the records from the people table, and then we'd have records from the places table. And then, the idea would be that immediately people come back and say, well, why not just put them all on one table? That's a great question, a naive question, because you might as well be using Excel spreadsheets if you're doing that. And a lot of times that's exactly what we see, is that people just keep putting the more and more data, these different columns in it, all these different attributes that, you got to scroll over. Whereas if we put it into a relational database, we can write a simple SQL query and be able to pull that data back lickety-split. And so it becomes quite interesting whenever we have this thing called referential integrity that says that, hey, if we have a primary key here, that primary key can be referred to by any of these other tables. We're going to go ahead and put it in. For integrity purposes, it always will check back. So, if I delete a record in this people table, all the records in the places table would need to also be deleted. Otherwise, the integrity would be squashed. And so usually that's one of the big benefits of relational database, is not only having unique values that are grouped together in different tables via the primary key, but it also gives us a way to interact with the data. Why is this important? Well, when you're dealing with 2 or 3 records, maybe it's not important to you. But if you're dealing with hundreds of thousands of records, that is when it may become more and more meaningful to you. So if I just give you an example here. So let's say I go out to the Ninja of Cyber, for instance, and management system, which is PHP MyAdmin, DBMS. And what we would typically see here is a bunch of different tables. I have one of the databases open, and then underneath it there would be maybe a users table underneath it, and you could see we store people's email addresses. We give them a promo key, and then you can see when they accessed it for the first time, and then we give some sort of expiry for it. Who's been doing what in the system, and have a log in there, and a whole bunch of other things as well. But being able to tie it back, in our case, a primary key would be an email address, because there's going to be a unique value for the email address, right? We only can have that one email in there. But from that, it ends up being quite interesting, because we can now link all records in that DBMS, the database management system, to that one primary key, and we can organize it in a little bit differently. And that is typically what we absolutely see with any relational database. So that primary key can be anything, but what it definitely must be, 100%, what it has to be is it has to be unique. Okay, it has to be unique. And so in this model that they give us here, relational database, they say the product. If this was your ISP, like your Verizon, this might be your SIM, right? Or your IMEI number. That would be, both of those would be unique, where they may hold that in a database table that allows you to then correlate other information to it. But in this particular regard, they have products, which both of those numbers, or both of those, are unique. Usually, just in my an alphabet character in there, it'll all typically be numeric. But This example, I think, really tells you a little bit about how relationship data or relational database at a very high level works. This is not a very good example, in my opinion, and this again is in your book, of a relational database. Over here, it says primary key. Well, to me, personally, being an expert in databases, I would never use names like this as a primary key. Why? Why would I not use those as a primary key? Personally. Not unique, right? I mean, what happens if you have a dog named Max, right? Or another Max dog enters the tournament. Well, then now we're in trouble. Now, of the same seed identities, which are primary keys, that essentially we probably would have to create another row right here. And that row, I mean, a primary key could just be an incremental number that is unique enough for your database. It doesn't have to be, a social security number. But then each time that you refer to that primary key, it's also referenced there as well. So here they also mention this thing called a foreign key. And the foreign key actually will point back to the primary key. So you could have, in this particular case, this looks like a shows table for dogs, right? This is probably a dog table. I don't know. I'm just guessing here. And in the show, so this is more descriptive about the shows rather than the dog. But for referential integrity purposes, we can refer back to Dallas here. And if we wanted to see how many shows has Dallas won and find out more information about Dallas, well, in this particular case, Dallas has only won one show here, and it was in Washington. And if we pulled back a SQL query for show me the shows that dog has won, there would be one entry for this dog named Dallas that would say Dallas is a dog and it's a lab, it's 85 pounds, the owner is David, it's black. But then in addition to that, it would also say it won show 3 and it was in the state of Washington. So we would join these two tables on the value that's same in between them, which is the dog, right? We could do that. And so that's where, that's exactly right. That's where it overlaps in between the two. So at a high level, that's really, what a relational database is. Is there any questions about that before I move on to the next thing? Anybody got? That's a great question. So we have not, with this exam, we have not seen any questions about SQL statements specifically. So they will not ask any questions about structured query language, especially joins. I mean, that's a little bit more complex, to answer your question. Called views, because usually this is what we see on the test. You may see a question about a view, and we mentioned this the other day, so I'm not going to spend a lot of time on it, but I do want to talk about it briefly, because a view, really, remember I said it the other day, it's a read-only subset of information. Okay, it's a read-only subset of information. And essentially on the fly here, Usually this is what we typically call it. This is typically what's called a stored procedure or stored query that is on or in the database that stored procedure query. Then on the fly, when that program calls the stored procedure, then it generates for lack of a better way, a virtual table for the end user, and that is a read-only virtual table that essentially is a subset of data. Okay? So we use views all the time. People use views all the time. Super effective. You can present the view however you want. You can join the tables together. The read-only. So and you can limit the exposure of the data, the entire database, to just putting. So a lot of times people can get quite confused about those, but some of the different databases that we usually, very popular ones that we see, Microsoft SQL, right? MySQL, Oracle. Those are usually for purposes of your exam. You may see a reference of one of these, probably just to tell you, hey, the question's more about a database. I'd be surprised if you did not see something on a database view. Okay, so if I was studying for this, I would make sure that I understood in database terms what a primary key is, view is. You will not be asked to write a SQL query, so don't freak out. All right, let's talk a little bit about change management, change control, and how important this is to anything in the software security realm. Usually we do that and enforce it. We can enforce, remember, you'll have a development team, you'll have a CM team, a configuration management team, you'll probably have a deployment team, and the dev team will submit it to the CM team. The CM team will then have to approve it. Once it's approved, they'll try to get it into a release at some point down the road. Usually this is governed by some sort of change request system. There's some big vendors that are out there for CRs and change requests, right? CR. But all changes need to be approved, documented, and tested. Now, not only does the actual CR need to be approved, documented, tested, doing needs to also be checked in, quote unquote, checked in. And what do I mean by that? The source code. So any type of code that you're writing needs to be under configuration management. Now you're probably like, well, Ben, I don't understand all that. Usually an organization will have policies, procedures, and processes that they've developed that will show you how to do as well. That kind of, for the first few days that you're there, you'll kind of watch the videos and get learned on it. But this configuration management, usually this is like a GitHub is one of the most popular ones in the world. Jira is another one that's very popular. Team Foundation Server. And both of these are Microsoft products, as well as CBS. What was that? Okay, what's it called? Okay, I don't know if I've heard of that one before. You guys use that? Okay. Subversion. But essentially, with the configuration management, you will have, it's a tree where if you're developing source code, there's a trunk of data, a trunk. And then underneath it, there's branches. And then underneath the branches, there'll be leaves that are developed. And everybody on the team can check in and check out specific is you're sharing files with each other. And so if I'm working on file A and Jennifer's working on file B, I can't go and make updates to file B while she has it checked out. So it's kind of like a library, if you will. It's probably the best metaphor that I've ever heard people describe it. It's just kind of like a library where you will check in and check out, the different pieces of driven environment. Usually people will go through change control requests like this right here, where they'll submit the change request. The change request will be validated, and then you'll probably have a meeting to make sure everybody's on the same page. Usually have a meeting of the minds, and then these other parts here. When I first got into one of the first projects that I deployed into a production environment, right after we deployed it into a production environment, and I had worked on it for a little while, we had over 500 change requests that come in within the first week. And, being a developer, CRs within the feelers. When I saw it the first time, I was just like, there's that many change requests? And so, I was, for probably an hour or so, I was probably like, well, shit, did I do something wrong or, gosh, and so I met with my boss and he's like, well, why are you down, Ben? I was like, man, we got 500 change requests. And he said, okay, so I was like, well, gosh, is there that many problems with the system? He's like, no, you're looking at it all wrong. Figured it out. He said, each one of those CRs, each one of those change requests means that you are gainfully employed for a very long time. Because if you have to come up with a cost and time or a rough order of magnitude, right, for each one of those, a ROM, then if one of these CRs takes, gosh, imagine if all of them take 160 hours. We're looking at 9,000 hours altogether. That's a ton. That's a ton, or 8,000 hours altogether. That means that you have 4 or 5 FTEs that are working just to write the code for that. Not only that, but to bring on people to help document, to then bring on people to test, But that's really what we're trying to do here. You know, we try to establish a CMMI. You try to constantly improve on the process and see how you can refine it with the goals, the end goals in mind here, to try to get a stable environment and make sure here, this is probably the most important thing about a change control, is that any modification is authorized. Because if it is not, if you put something into a production environment that's not authorized, all hell loose. I actually was working at a place where somebody made a change to a firewall. There was a priority 1 ticket that came through, and one of the engineers thought he had approval. This was his story. He thought he had approval to go ahead and make the fix because it was a high-profile customer that made the change request. So he went ahead and made it on Friday. It wasn't approved. The change request wasn't approved. And so when people came in at 8 a.m. on Monday and he didn't actually go in and document what he did, he just made the change. It wasn't approved, right? That change was not approved. Nobody knew that somebody had made a change to the environment except for him. And because of that, pretty much all day Monday was spent trying to find out what happened. You know, he starts saying, what's going on? Well, you know, somebody made a change on Friday to the firewall. You have any idea what's going on? Oh yeah, I mean, I was working on ticket 1, 2, 3, 4, and I went ahead and made the change. Well, you know, we got a process here, right? Let me just remind you of the process that, you know, you got to document everything, but more importantly, it's got to be approved. And so that dude had to go through some awareness training, and I agree. So one of the most important things when we're implementing any type of test that's out there, you know, we want to make sure that we have a bunch of different ways that we can go through and test things. So at a unit level, let's say that let's say I have a new airplane, right? And we're developing a piece of software for what we're going to call the glass cockpit right here. Okay. So we're developing a piece of software for the glass cockpit. So if we kind of blow that up a little bit, you know, the glass cockpit here has a number of different things here. Has 6 different things that it needs to be delivered upon. What we would need to do is we'd need to discuss what these 6 things are, right? We would have to come up with the requirements and go through functionally how we want to look, and you know, that takes a long time. And then we would start to develop. Well, what we would do is at a unit level, each one of these. So, you know, this number 1, we may break that up into, you know, 8 different units, right? And so each individual unit here of number 1, we would code it out, we would get it to work, and then independently, we would test each unit, right? So each unit here would be tested and so we would do that for each one of these. We might have 6 different teams that are working on this, knowing that this project is probably $1 billion. we'd probably have a bunch of different teams that are working on it. And so each one of those would have, unit testing that would need to be done. Well, once the unit testing is done here for number one, what we would start to do is we would start to take 1 and 2 and begin to integrate, right? So that would be that this is usually at a small layer or small level, or at a unit level. So it's something small that we can test to see if it works. Usually what I'll do is first I'll go to the data personally. I'll get the data how I want to look at it, maybe through a SQL query, if there is a database of some kind. I'll get the data how I want to look at it, and then I will start to build and write something from the command line, and then I'll take it up a layer of abstraction to then can I do it from the web server and kind of move up the food chain that way. Because if I start down here at a low level and I got it working there, then I can eliminate any interactions with the database, which is usually the most difficult thing for people. So the integration means that you go through and you take you are testing it to make sure that these two have what we call typically interoperability. And this is where we may end up looking into what's called an API, which would be an application programming interface, right? And this API, especially when we get into integration testing, because it essentially, instead of having to write code from 1 to 2, or let's just say over here at 1 I have A, B, C, D, E, F, G right here. If instead of me having to write an interface for 1 to 2A, 1A to 2B, 1A E, 1A to F, for me to write 8 different interfaces here, what I might do is on 2 here, I write something for people to be able to interact with me via an API. And then at that point, I write it one time with maybe 8 different functions. And then I give you the documentation, I give you sample source code. And then from that point on, you plug and play, and now it works beautifully. That's typically the approach that we see in so once you're done with the integration testing, then we get into what's called the acceptance testing. And the acceptance testing, typically, you'll come up with a test plan with something making sure that the customer here, right? So the customer has distinguished acceptance criteria. So what does that mean? That means that basically, what does the customer want? And have we met it? Have we met it? So then the customer really will check and see, have we met what the customer is looking for? Have we met it? And then probably the one that many of you are familiar with is the regression testing. So usually the regression is anything dealing with any previous versions of source code or software. Who's that keeps going in and out here? I'm gonna have to get rid of it. Is that user 1 that keeps going in and out again? we may go through and do, buffer overflow. We may look for buffer overflow attacks. We may look at bounds checking. There may be a number of different things that we may do. Just give me a second here. Nope. All right. So regression testing looks for previous versions of source code or the software and make sure that it works with those previous versions. And that's typically what we see for regression testing. Any questions on that? Anybody ever been involved with that before? Sometimes we see questions on this word. And, for me, 20 years ago, I wouldn't have been able to describe this. But now, being a handyman, I can tell you, no, I am not for hire. But you never know what the good Lord has, right? Being a handyman, I can tell you that I about plumbing. So if you're familiar with plumbing, then you may know that a coupler typically will take, usually it has a little lip on it in the middle. Usually it'll take a maybe a larger pipe, smaller pipe, and it'll allow you to take those two pipes and be able to connect those two pipes accordingly. So it maybe over here is a 2-inch pipe, maybe over here is a 1-inch pipe, and so this coupler allows you to have these two pipes that move whatever you want to move, water or whatever between them, right? And so when I see this word, I oftentimes think about, okay, in plumbing, that's what a coupler is, right? That's what I'm doing. Well, if we have a loose coupling, then usually that means that it's not related in the software world. So it can run standalone. Usually it can so loose coupling means that it doesn't need other libraries to be able to run. It can run on its own. Whereas a tight coupling or a strong coupling, referred to as a high coupling, says that it needs other libraries to run. It's tightly, then it will not run without those other libraries, right? It's not going to run without those other libraries. And so what we typically will see is maybe a question on the exam about coupling in regards to whether it's a loose coupling or a tight coupling. and they may refer to it as some of these other keywords here, but hopefully, that example would remember it a little bit better. We got any plumbers on here? You done plumbing? Okay. Are you for hire? Yeah. You know what? It's funny because and I'm not, maybe it's not funny, but my kids, they look to YouTube for funny stuff, right? But me, and I don't know if it's just, if I don't know how to do something, first thing I'm doing is going out to YouTube. And for me, I thought everybody's like that. But my kids, it's like if they come and ask me questions, Dad, how do you do it? Well, did you look up on YouTube? No. Well, why not? You're watching every flipping else thing out there, how come you're not watching how to do a compound minor solve? Well, I hope that you're not going to use that by yourself yet. Or how to make a that's tight coupling, loose coupling, and you may or may not have seen that before. All right, so the last thing that I want to talk about here, and I'll leave the rest of this domain okay. I didn't see that until just now. Okay. You're a plumber at a couple of houses. Okay. Haven't seen that until just now. All right. So what I'll questions that you may have about any of the other domains, obviously, for our review, when we go through and do that review that we'll talk about in a little bit. So one of the reasons, not the main reason, but one of the reasons why Microsoft has been is the forethought of saying, hey, if we got something that people are using, how can we put them in a position to, maybe be able to interact with us? And early on in the Microsoft life, they started to develop what's called the component object model, and then the distributed component object model. This is abstract, so just go with me here for a little bit. So Microsoft created this COM, and then a lot of other vendors kind of followed suit afterwards. But the COM really gives a standardized API, which is an application programming interface to Microsoft's products. And what it does is it really allows for any inter-process communication. That's really why they named it the COM. So it allows inter-processes to communicate. So what does that mean? That means that if you're running one application over here, right here, and let's say that this is a Microsoft application, what it allows you to do is it allows you to tap in here, kind of like a keg, right? You can tap into the keg or tap into the Microsoft here because they published the API for the COM right here. And so what does that mean? That means that if you want to interact here, if you want to interact with any Microsoft, if I want to use, maybe Microsoft Excel to do some number crunching. I can interact with the COM using their API, Microsoft's API. Why would I want to do that? Well, maybe I want to use it to do some analysis with some built-in functions within Excel. Or maybe I want to interact with Azure. I can do that, right? But the first example that I gave is with COM here. This typically is on your machine or encased in the machine. So if I write an application, you install that application can interact with the Microsoft COM on your machine, right? So that's the component of. Whereas the need began to manifest itself for this same kind of thing to standardize the API for Microsoft platforms and products, but to also allow us to do that same sort of component interaction for any distributed, let me write this down, distributed interprocess communications. And usually what we call that is IPC, interprocess communication. So what does that mean? Well, DCOM is kind of cool. It allows us to access that reside on different parts of the application, of the network. And more importantly now, more than ever, the internet. This really took, from a closed really environment on your machine to now it extends it up to the world. Now, obviously, going over the internet, there's other things to consider. How are you going to get access to that machine over the internet? But on your own LAN, we can interact with just about everything if we have access. And so being able to do, like if I make a call to another server that has that's running a Microsoft SQL server, instead of me doing all the processing on my machine, I can send the request over to there. That server, which is a high-end box, will do the processing. It'll give me back the whatever I asked for if I have access. And so by doing that process-to-process communication across networks, really revolutionized everything in this chapter or in this domain. There's a lot of really neat things that they review. But one of the things that is quite interesting is if you've never done this before with COM and DCOM, a lot of times on the back end, you don't even see this stuff happening, but just know that it absolutely does happen on the back end. One thing to consider here, let me see. Is, and a lot of other vendors have started to do it, which basically they allow you to use their software to tap into the COM or the DCOM. And in this particular case right here, just looking at it, this says, C#, VB.NET, PowerShell. There's some sort of compiler. And then there's a .NET, and then a common language runtime. So all of that could or could not mean anything to you, but just know if it was native to the machine. So if it's on the machine, this is how it would work, and that would be common, right? If this goes across from your machine to somewhere else on the network, that would be decom. And there is a you immediately introduce some security risk with that, right? If I make things accessible to other parts of not only my network but the world, now I've increased the risk significantly. My security boundary now becomes much larger. But by Microsoft doing that and creating an API, application programming interface, to allows you to interact with the world to a lot of different things, and you can have a lot of great flexibility with their software. Okay, any questions on that? To me, that makes sense, but usually if somebody hasn't heard of an API before, that's difficult to understand. If you have heard of an API before, I've seen it introduced like this, but certainly that's the way that Microsoft does it. I'm not saying that's the right way, but obviously they're the biggest software company in the world, so they must be doing something right.
So would a decom example be like when I have an application that secret statement, but the actual processing of the statement database server?
Yes. So decom would absolutely 100% mean you have maybe like a query analyzer running on your machine, or Toad or something for SQL, structured query language. You can, through a connection string, connect via decom to a remote SQL anywhere in the world, this remote SQL database anywhere in the world, as long as you know on it. Through decom, it'll take that connection string and then link you up with that. And then there's a lot of other things that come into play, right? So there's object link and embedding, OLE. There's OLEDB, where it's object link and embedding with databases. There's ODBC, Open Database Connection. There's JDBC, if you're writing Java code, Java Database Connection. But essentially, all of those are decoms. I have that link that goes out, and I can interact with the processes anywhere in the world. I run the query from my machine. I send it across the wire. It hits there. Do I have access? Am I able to run that query? Okay, go ahead and process it. It'll do all the crunching over there and then send it back to me. So that's why usually those are lickety split, is because you're using a server that's much more robust than my machine. Maybe it's that machine has been provisioned to do just that function. And that's typically why we have different machines on the network do different things, so we can use decom to interact with those machines. Like you have a separate Active Directory server, you have a separate PKI server, you'll have N number of SQL servers, you'll have different web servers over here. Those web servers will connect to the SQL servers. We locally here can connect to the web server. We can connect to the SQL server. All of them are using decom, that if it's going in between. If it's innate to that box, it would just be com. If they're Microsoft products, right? Because Oracle has tried to copy, and they call it something else, like a Corba, or I don't know exactly what. I don't use a lot of Oracle stuff anymore. But good question. But more importantly, did I answer your question? Okay. sometimes I feel like I get a little excited about things. So I may be quite verbose about my interpretation of it. So one of the, before we transform and roll out to the next domain here, I think to me, this next thing that I'm going to show you really, to me, and this is in your book, figure 8.36, and I'm just looking at the online version here of your book. But to me, this is really the glue of everything we just talked about in how this interacts, right? So let's check it out here. We got a browser or an application up top. It may be using ActiveX data objects here. Edge, Safari, they all would use that. And usually this is kind of for higher end graphics. ADO controls usually come in for higher end graphics. You may have seen those before. The OLADB allows you to interact with different types of data. So if it is something that's not SQL information, this is essentially a proxy that translates the request from you to these old school things, or the things that are not SQL, like LDAP would be directory services. So you would use an OLADB control to communicate through a browser to same thing for like Exchange or WebEx or things like that, right? So, but if it's a database, on the other hand, the application would then use the OLADB, which is the object link and embedding database, and then would connect to the database server with the open database connection string. That's what ODBC. And then it would be able to interact with structured query language, server, Oracle, MySQL, other types of SQL interactions. So we would make that open database connection here and then be able to connect to any database in the world by these levels of abstraction here. So that's just a cool little diagram that they have in your book that may be helpful when you reference any of these. Let's go through and talk for a second, see if you know anything that we just reviewed. Just for your own personal enrichment as well, I may end up going a little bit past 4:30 today, just to make sure that I catch up. So just letting you know, if you got to leave at 4:30, that's fine. But I may end up having to go to 5 today. Hopefully you're okay with that. If not, feel free to leave whenever you want. All right, let's go through and talk about this. All right, here's a term that we've used a few times throughout the week. It's kind of a silly term, but I'll go ahead and put it in there. I am recording today. So this is the act of sending data, random data, to a target. So I'm testing, right? I'm sending random data to a target program in order to trigger failures. Alicia, yes, that's it. Good. Ryan, no. But that could be part of this type of test. I'll give you I got a little bit of this going on right here. We used to call it back in high school, we would call it something else than scruff, right? We would call it, yeah. And there actually is a program that's called, that word. Yes, Jennifer, that's it. What's another name for scruff? It's not scruff. It's Jennifer. Now that you know it, do you know what I'm thinking of? Don't say it out loud. Okay. So Georgia is known as the blank state. You eat these fruit. That's fruit, right? Yeah.
Well, I mean, I get where we're going.
Okay. There we go.
Okay. I got you now.
Yeah. So I was looking for fuzzing there, and the tool actually, you can look it up. There is a tool in Kali Linux that's called Peach Fuzz. Yeah. This is actually a fuzzer. It does have SynFlood in it. It does, buffer overflow. It'll try to do buffer overflow attack. It'll try to do a bunch of different things. So there we go. So these types of vulnerabilities are vulnerabilities that do not currently have a resolution or solution. Yes, Brian. Good. Doug, yes. Alicia, yes. Brandon, yes. Good. Yes, good, Annis. We were looking for 0-day right there. These types of vulnerabilities are vulnerabilities that currently do not have a resolution. This. Let me see if you know this. I don't think we've talked about this. I'm just going to see if you know it, though. So we have partnered, Cyber Protects has partnered with this nonprofit organization. It's an open source project dedicated to helping the industry develop more secure software. We've actually done assurance summits here in town over at the Jackson Center with these guys. Close. MITRE works a lot with these guys too. No? Doug, no? Four, right? The Open Web Application Security Project. And it's really good. People like me that consider experts in the field would volunteer for OWASP and collaborate on different projects for open source, for release in open source. But also, they've asked for me to come and present at different chapters around the United States. I've asked for people to come in and present at different chapters. So quite interestingly enough, it's kind of cool. Anybody who's in software may want to be taking a look at that. All right. How about this one? Yes, Ryan. Good. Jennifer, good. Alicia, good. All right. Yeah, Doug, good. This model This model uses 5 maturity levels designated by the numbers 1 through 5. That's right. So CMMI is what we were looking for there. This next one's a little bit long, and I made sure that I did not give you the answer inside this one, but there are some words that are the answer in here. So blank blank needs to be put into changes must be authorized, tested, and recorded. The changes must not affect the security level of the system or its capability to enforce security policy for 1 billion points. Yes, Ryan, good. Yes, Jennifer, good. Yes, Amos, good. Doug, good. Usually it's Doug, it's the other way around. Those 2 words, other way around. But yes, you're right. Yeah, that's right. Management for that last one, I would have accepted either one of them. So good to everybody who got it. How about this one right here? We just talked about this, so it should be hot and heavy on your mind. I'll even accept the acronym if you don't remember what it actually stands for. But 3 words. You can give me the 3-letter acronym if you need to. Provides an architecture for components to interact on a local system. I should say on a local Microsoft system. Ryan, yes, good. Jennifer, yes, good. Alicia, yes, but there's another word there. Another word, but yes. I actually like the word you gave me better, but that's not the answer here. More than they know the actual answer to this right here. Yep, that's it. Good. Amos, yes, fantastic job. So there's quite a bit of different types of attacks that I didn't review in here in this domain that you probably already know. I'm assuming that you already know it. That's why I didn't review them. One of them is this one right here. So for that last answer, I was looking for COM. For this one, what is this? The type of attack are networks of bots that are controlled by command and control servers. So Ryan, that's what the individual bots are also called right there. What is the thing? Yeah. Okay. Overall. Doug, yes. Alicia, that's what the individual bot is called. So you're in the ballpark. So what I was looking for that is a botnet. A botnet. All right. Good. How about that one? Jennifer, yes. Doug, yes. Amos, no. Yes. But no, that's not what I was looking for. But you would be correct there. But that would be a type of, yeah, Alicia, good. Good. Ryan, no. All right, this type of attack is a program that performs useful functionality without the user knowing it. So that's a Trojan, like a Trojan horse, like the ancient story of Troy. They gifted him a horse, a wooden horse that inside had all the warriors inside of it. You may recall. Okay, I think this will be the last one, and then I want to show you a tool that we have that you can use. So a database bank row is located from other parts of the database in a relational database. There's 2 words here. And if you miss it, we're going to go do wind sprints and crab crawls out in the parking lot. Good, Jennifer. Good. Ryan, good. Doug, no. Okay, that's fine. I like that. You shithead. All right, Alicia, good. Doug, you got it. Fantastic. All right, the second word sounds like, well, the second word is key. How about I give that to you? The first word is what? We talked about 2 types of keys. It rhymes. No, I can't say that. All right. So that one, yeah, primary key. Good. That's what I was looking for there. Good job. So one resource that you have at your disposal that you may want to take a look at, and that is hackme.cyberprotects.com. So if you go out there, we're using open authentication. So you sign in. And when you sign in, it brings you to this splash page here. And really all that we do with that authentication is we're taking a look to see who signed in. Okay? Up here in the top left, you can see that's what Google passes back with open authentication. Okay? So underneath the hood here, this is a system that you can go and play around with here. Hackme.cyber. Use the OWASP top 10, which are published in 2017, but still very, very relevant here. And one thing that I would challenge you to do is to go and see if you can do Sql injection. So bypass Sql authentication. You click on that, and then in here, see if you can type in a Sql injection. Your lucky day. Over here, we got some hints where you can go and look up bypass authentication, and then it shows you exactly what you would need to do to make that magic happen, okay? I'm not going to go through it right now. But if you go to bypass authentication and use Sql injection, that's one really good one that'll teach you about that more. And then if you go to cross-site scripting here and add to your blog, you can actually do this particular website. So you can do it to your blog, you can do it to somebody else's blog. Again, you do have permission to go in and do it here. Cross-site scripting. If you're like, yo, man, I got no idea what you're talking about, well, guess what? We got hints and videos that you can watch here. If you wanted to learn how to do cross-site scripting, guess what? Boom, we got this hint in video. And I'm not going to spend a lot of time on this here because you won't actually have to do this on the exam, but you may have a question on SQL injection. You may have a question on cross-site scripting. So if I was to just do a simple cross-site scripting attack where I put in a script, again, I just copied it from here and I pasted it in here. And I paste in what a little bit so you can see it. Ben was here. I can save the blog entry, boom, and see what happens when a cross-site scripting attack, just a basic one. I can go in and make a pop-up or an alert box happen. And the next person that visits here would very, very quickly be able to see that they have a little Easter egg waiting for them, and that's a pop-up. So I can maybe have a drive-by download where it downloads something on your computer. So cross-site scripting is alive and kicking. And what I would imagine is that if you go out and play with these out here at hackme.cyberprotects.com, you would be in much better position to understand what these actually mean, some of these different types of attacks, okay? So this is a great resource that we put together for you to see if you can break. And I would encourage you to use Hackme. That's hackme.cyberprotects.com. Sound like a commercial there, huh? All right, let's take a quick commercial break here. Speaking of commercials, take a quick commercial break of, how about 7 minutes? Come on back at 2:02, and we'll keep the dream alive for you here in 7 minutes. 2:02, we'll see you in 7 minutes.
y'all had anybody actually take down the hacking side? Close to it?
No. We've had it up there for 3 years. We get over 40,000 attempts per day.
What's probably the worst?
Well, I mean, people are constantly trying to brute force attack it. Probably a denial of service attack. I mean, we've not had a problem. We host it in a load balanced environment, but usually it's usually we don't have any problems with availability. We use SSH, and for that one, because we called it hackme.cyberprotect.com, for that one, what we did is, for that web server, what we did is we use a private key to connect SSH to it. And so there's 3 on it, and those are the only 3 machines that can access that web server. So, I mean, these other people that are out there using these automated, whatever automation that they're using to try to get into it, I mean, if they don't have the private key, they're not going to get on it. And we did that on purpose, and it has stood the test of time. But it's running MySQL. It's got PHP on it. No. If you go out and play with that, like try to go out and play with it. If you go out and play with it, a lot of times people think that from a pen tester perspective, a lot of times people that are not trained in the ways of the Jedi for the pen testing components, what they'll do is they'll see an error on or an exception on a web page, and they'll think to themselves, okay. Whereas I'm thinking to myself, I'm looking at that error, because in that error, if I get it to be able to error something out to me, it's going to tell me everything I need to know about that web server. It's going to tell me, is it running Apache? Is it running on a Linux server? Is it running MySQL? Is it running PHP? Because a lot of times, if I can get them to behave in a way that throws an exception, then it'll also tell me the database table name, the query that was run that throws the exception, right? And so when you're going in and playing with the Sql injection, especially, you'll see in there that it will throw an exception. But if you look at that stack trace, it'll tell you everything you need to know about that database table. Now, what does that mean? That means that, at least for that site, that's a very vulnerable website, it can go in and hack into it, because we get people that are very interested in learning more about all those different types of attacks, especially SQL injection, cross-site scripting, cross-site request forgery, and the whole litany of other things. But because there is, because you have to authenticate, we force you to authenticate first to it, instead of just throwing it out on the internet. That's a layer of protection that we put in front of that thwarts a lot of the attacks. But I mean, from the back end, people try to just authenticate to that web server without a browser, through command prompt. And because they do that, we're under attack all the time on that web server. But I mean, we got that thing locked down. And I mean, it is does offer up a lot of flexibility for the different types of attacks that are out there. So people enjoy playing around with it. And I would encourage you to go out there and see if you can break it. You know what? I'll give you another shirt if you can break it. Yeah. You know, we'll throw it in there. Nice guy I am. I tell you what.
Special order, you get the order.
You know, that's the way we're gonna do it. That's the way we're gonna do it. All right, let's keep on trucking here. Keep on trucking. I want to jump into security operations here and talk a little bit about that domain. But before we do, you know, I don't want to be in a big rush here because, you know, I've done this before. This ain't my first rodeo. I know we're going to make it through to the finish line. So you guys just have to be patient with me. What I'd like you to do is, instead of us reading out the questions out loud and kind of enumerating each one of them, what I'd like you to do is you got 30 seconds for each one of these questions that I'm going to put up here. What I'd like you to do is put in what you think your answer is into the chat window, please. Everyone who has submitted an answer so far is correct. Good. Alicia, I have failed. I have failed. Brandon, yes. For me to see that answer, Alicia, I have failed. And I say that with affection. Correct answer. A is the correct answer. Oh, it's not me, it's you? Okay. All right, what about this one? We got 30 seconds. Jennifer, no. So now you got a 50-50. Doug, no. Amos, no. Gosh. Wow. Oh, boy. Ryan, no. Lord have mercy. Alicia, no. Doug, yes. Oh, answer isolation. I like that. They also say that a blind squirrel every once in a while. No, that's something totally different. I didn't officially say it, right? I like that. Answer isolation. Yeah, so you know, we talked about this before, and I'll say it again, that one of the biggest problems that we have is input validation. Input validation, right? So if we do proper edit checks on applications through, if you recall the model here, the Clark-Wilson television production, right? The Clark-Wilson model. Remember that that's an integrity-based model, right? And what it tries to do is it tries to have integrity verification procedures. If it's not in a proper format, it'll transform. And in addition to that, it will also have a CDI, right? The constrained data interface. And so anytime you're thinking about that, an application, think about integrity. How can we do integrity? Usually input validation is the second biggest issue. Number one is misconfiguration. People just stand it up and they don't. It's totally wide open, totally wide open. All right, so the answer there was bravo. Let's go to the next one. Yep, Ryan good, Jennifer good. Oh, come on, Doug. Yes. Amos, yes. So I like, Doug, I hear what you're saying. A lot of people feel like that. Alicia, yes. One of the reasons why I like to do these and kind of, you know, methodically go through a lot of questions during the boot camps is because you need to see what you're up against, because these are going to be questions like you've never seen, for you to kind of get an idea of them. Let's check this one out real quick. I'm not going to spend a lot of time because I'm running out of time, but I look at boom and boom here, right? And I don't even read the rest of it, and I just get rid of those two. So for this one, A is the best answer. At least I got myself down to a 50-50. I mean, that's kind of funny right there. Avoid the need. Number 4, the use of databases usually provide all the following except which one does not fit? They say if it don't fit, you must have quit. Amos, yes. Jennifer, I'm so sorry. We do have some nice partying gifts for you after the show. Brandon, no. Alicia, no. Ryan, no. Doug, why did you go with that answer? Amos, why did you go with that answer? You two are the only ones that get it so far. Yeah, normalized information. Good. I like that. Narrowed it down between those two. Okay. Yeah. All right. So it does. But databases add additional risk to the disclosure of data by making it more integrated and data available to a larger population. The risk is often addressed through the use of database views. So C is the exception here. All right, let's go. Database is not controlled by. Now, remember, ISC squared doesn't care what you think. They call things what they call things, not what you call things. I'm not just pointing at you two, I'm also pointing at everybody here. All right? Access to data that is stored in a database is not controlled by. Doug, yes. Jennifer, no. Not, I'm telling you, there's one flashy one here that everybody always picks. That everybody always thinks is the right answer, but it's actually the wrong answer. No. Jennifer, yes. Boom shakalaka. Right? That's the sexy looking one that people just say, oh, yeah, it must be that. Amos, no. It can be. Right, Jennifer? I mean, you look at it, you're like, yeah, it must be. Right? But do you actually call? I don't know. No, you don't. You don't actually call them that. I mean, but when you look at it, objectively here, you're like, oh, yeah. But no, there's not actually a role that's called that. So D is the best answer here, not controlled through the security administrator. Check it out. In most cases, the application is what calls the proper view of the database. This is the first layer of access control to the database. Then the database management data is maintained by consistency checks. Usually, the security administrator is not in charge of the database. The database administrator is. They deliberately try to trick you there. So D is not controlled, right? All right, let's keep going. We're going to do 3 more of these or 4 more of these. This should be an easy one, so choose wisely. I'm not going to say anything there, man. I mean, come on. Come on. Jennifer. He answered the same thing you did. I'm going to say WTF for that. Doug, yes. Alicia, yes. No. I'm interested here. Why wouldn't you have picked that one first as opposed to the one that you picked first? What does that one mean? What does D mean here? What does delta mean? T, what does that mean?
Adding like new network configuration. Like how many?
Okay. Like to me, I look at that one and I think that's not part of configuration control. And it says project here. So I'm trying to lead myself to the right answer because immediately I would throw out D. D would be for me. And then I would then get, you know.
I say I immediately threw out B and C. I thought, it's too late.
So I mean that's why they call this a managerial exam, because if you know what a lot of these terms are, you should be able to. If you know the term, then you should be able to at least eliminate it. But it is going to be blatantly. A lot of times, it is going to be the answer is going to be blatantly obvious to you if you know what that term is. If you don't know what the term is, you can't either eliminate it. No. So the correct answer here, we did get some people get it right. Doug, Alicia, and then subsequently Ryan. So scope creep is the expression used by project managers and or vendors who are always under pressure to constantly deliver in excess of what was originally needed. Usually, scope creep results from a failure to establish clear requirements of business users. This is a tough one. This next one. All right, if you've submitted an answer, everybody but Jennifer, you are wrong. Jennifer, good job. You're my star student.
Yeah.
Or, kind of like what I tell my kids when they do something for me. You're my favorite right now. And then somebody else will do something for me. You're my favorite. Hey, you've always been my favorite. Doug, yes, you're my favorite. Amos, yes, now you're my favorite. And once you get the answer and you reread it, you're like, yeah, that one really makes sense. Wow. All right, so protection of source code is concerned with all the following. All the following, right? So separation of duties, restricting programmer access to production libraries. Yeah, we're concerned with that. We don't want production. We don't want programmers to have their access. Yes, absolutely. We want to protect the intellectual property, and we want to ensure that source and object code, so source code and object code libraries contain the same version. Absolutely. If it does not, then we are in trouble. So the only one that doesn't fit here, and it's more of an application, right? It's more of an application component. If it runs in the wrong sequence here, fit. These other ones kind of protect the source code. That one doesn't. That one doesn't protect the source code, in my opinion. All right, let's keep going. Oh, hold on, let me go back one. Let me see if it had notes there. Maybe I could go. No notes for that. Okay. Oh, this is a good one here. This one should be easy. This one should be easy. Shiny ones here, though. So choose wisely. All right, what's the manager's answer here? What's the manager's answer here? Doug, yes. Alicia, yes. Amos and Ryan, no. Jennifer, no. What's the manager's answer here? Ryan, yes, that is correct. All right. What's the manager's answer here? I mean, from a technician's perspective, totally agree. That is, I mean, there's always going to be two answers for each one of these, but which one's more of a manager's answer? And obviously, we don't want that to happen, right? We can definitely eliminate this one because who's to say that we can't use 256-bit encryption? Enable users to make any changes to their personal information? No. We don't want to enable users to make any changes to their personal information. And so now we got 50-50. I would say, you know what? D is probably correct. Yeah. But A is a better answer than D. We don't want to give unauthorized web application in the DMZ, and it has a hook back into an internal database. A is one of the most blatant fouls that we see when we're going and doing penetration testing, is that somebody has a web application that's running out here, and it's got a hook back into an internal database, and we can get access to that database and then pivot a database. We escalate privileges, so privilege escalation, and then we pivot, quote unquote, to another internal resource. And I mean, once we get internal access, it's on like Donkey Kong. We can do just about anything we want. Right there. Okay, I think I got one more here, and then we gotta keep on trucking. Now, this one I don't really like the wording of it, but whatever. I don't run. I mean, all the real answer here in my opinion, it could be something different. Ryan, yes. Jennifer, yes. Both of you guys didn't answer that question correctly. What should be the right answer? Doug. Guys, what should be the right answer? Yeah, that should be the right answer. That's right. Alicia, what should be the right answer, though, for this one? Same thing to you, Amos. Yes, you both got it right. But what should be the right answer? Jennifer, good.
I said, feel like they put that in the question basically.
Yeah, you're right. I agree. But been kind of harping on the data owner. And yeah, the data owner really is part of a business unit. So the superset of data is owned by the business unit. The subset is owned by the data owner. But if you're going to put data custodians in here, why not put the data owners, in my opinion? So business units are good. Now, I like doing these questions personally, just because what's going on and what to expect. Let me see if it's a gut check. Good. Yeah. That one's kind of funny. This one's kind of, I'm just going to show it. This one's kind of goofy. Yeah, that's right. Ryan, good. I think it's kind of funny that one of these answers here, they totally try to get you to pick if you don't know. If you're a sucker, you may pick one answer here, Jennifer. No, I'm not saying that you're a sucker. I'm just saying that you may pick an answer here. And that answer, if you're a sucker, may be C. Because in my opinion, right here, just knowing a little bit, this and that really do not go hand in hand here. I think about it, and it used to actually prompt you saying, "Do you want to download an ActiveX control?" You guys remember when it first came out, like probably 7 years ago, 8 years ago, and people would always say, "No." Click it off. No. That's because it was very insecure, a lot of vulnerabilities with it, and then browsers started to block it. So then Microsoft said, "Okay, we got to figure out a different way to do it." And now it was put onto the server side, so the browser doesn't have to download the ActiveX control anymore. So C is not the right answer. Right? Don't pick C. A is kind of a shiny one, but no, A is not the right answer. And these are actually mobile device technologies, right? Mobile cellular technologies. So they're trying to get you to think, okay, mobile code, I think of like Java, where it's cross-platform. It means it's mobile code. It's cross-platform. Bravo would be the sandbox. That sandbox is something that contains it. It contains it. All right, last one here. Actually, there's two more. I got to do these both. I got to do both of these. I know I'm encroaching on 5 o'clock. I feel like it's the right thing to do. Software copyright licenses may be exceeded when. So let me just tell you here with this one, don't pick the wrong answer. Don't pick the wrong answer with this. This tells me a lot about you if you pick the wrong answer.
I like pizza. Maybe copy it.
Yeah, right. Ryan, yes, that's the right answer. Good. Amos, that's funny. Doug, that's funny. Doug, yes, that is correct. Jennifer, is that what you guys do? So let's, when I think about this right here, I don't know about what you guys think of, but I think of immediately, I think of all these machines that I want to put Windows on. Do I need a license copy of Windows on each one of these machines? That's the question. That's the question. And from a small business perspective, over $100 to license each one of these machines. But that's the right thing to do, right? So C is the correct answer. Certainly, I think A, if you're maybe taking it for a trial, or you want to stand something up in a prototype. B is just kind of funny. Be great, but no. So C is the best answer here. Yeah, absolutely, Doug. We were able to do it back then, right? Microsoft has gotten a little bit smarter with the way that they do licensing. Yep. So C is the right answer. All right, this is the next one's kind of a tricky one. Remember, you don't answer it out loud, but what's their primary function in life? So anytime I see this one word, I always pick it. I always recommend that people pick it. Even though you guys are going to probably agree with me here, even though that probably doesn't work. That's like the carte blanche answer there to overcome, right? Jennifer, yes, good. Ryan, good. Doug? No. Doug, no. So ISC Squared is primarily a training company, although they have tried to get their hands into other things. Doug, yes. C is the best answer. C is the best answer. Good. All right, so hopefully that's somewhat helpful. I kind of feel like I want to give you more of these questions here, and then I can PowerPoints here in a few minutes. But let me just see here, because a lot of what we're going to be covering with these slides here are things that some of them are things that we've talked about already. But That'll give me a good way to break it up. Security operations, and then I'm going to pepper in a few questions here when I start to see people getting that glossy eye look after a few minutes. So what are we trying to do with security operations or operations security? In order for us to effectively try to roll out a security program, we need to be able to make sure that we're identifying a team. We got to have a team. Call on in case we need help. In addition to that, we got to be able to hopefully have that team help us to identify any vulnerabilities. And then, we obviously got to work with management. Level. And then finally here, we want to make sure that we can derive baselines. And in order for us to do that, setting that minimum level of security, if you recall, we got to figure out how to detect, assess, and recover, right? Those are the things that we're interested in what we need to do in order to be successful here, especially with security operations. And so we have these things that would typically within an OPSEC we call zones. And it's very similar to those layers of the onion where essentially, whatever we're trying to protect with the critical sense, we're going to go ahead to make sure we protect those investments over the long haul, right? And that's really what we're trying to do with it. Now, you may be familiar with this thing that's called the defense in depth approach, because we have talked about it throughout the week. But there are, especially in the physical side of the house, there are quite a bit of threats that can come into play, especially in nowadays, especially this timeliness of politically motivated events that are happening, whether or not you agree or disagree with them, I don't care, because that's not going to be on the test. But if we don't talk about that, let's talk about natural environment threats. Give me an example of that. What could that possibly be? Yeah, tornadoes here, right, in the Hunts Vegas area. If you're down in along the Gulf or the Atlantic, maybe hurricanes. Out, a lot of different things to think about. What about supply system threats? That's kind of an interesting term. What could that possibly be? Yeah, railroad, whatever issues are with railroad, truckers. Apparently, 75% of everything that is in supply chain goes with truckers. Here, especially for some of those remote spots out west. If one of the transformers breaks, then those people are SOL. One of the things that if you see any questions on the exam that give you an option, what is the most important? The answer will always be life safety. So the safety of your employees, and you probably will have two questions on what, and I think that goes being unsaid, but you probably will see a couple of questions, and if you see that as an option, even if you think it's not the best answer, pick it, because human life safety is always the right answer. And we've seen that over the years in teaching this boot camp. The layered defense, I'm not going to talk about that again. We've already talked about it. But when something does happen, what do we need to do? Chain of custody. Why don't you put in the chat what you feel is the answer to chain of custody? What do you think chain of custody is? Put it in the chat if you don't mind. Good way to look at it. Yeah, intended to maintain. Yeah, that's right. Maintain integrity. Good. Usually, what we look at is chain of custody is usually a history. Analyzed, transported, preserved in order to be presented in court. So usually when we're doing any type of operational security and there's an incident, we need to investigate the incident. We want to make sure that everything that we're doing is recorded, and that includes but not limited to collection of things, being able to analyze those things, especially in our world. I always think of the poor guy when I was working at NASA. Well, I guess shame on him for doing it. But when I was working at NASA, he actually had. They used to allow us to do instant messaging over various IRC, the internet relay chats, so you could use whatever you wanted to, but people were watching. And this one guy on the team that I was on, he actually had a guy that worked at another company that he was doing. I don't even remember what they call it, but he was sending images back and forth with this buddy of his that were of people doing things with animals. And I mean, I can't really make that stuff up. Yes, bestiality. Thank you. I don't even know how to spell it. So this guy was sending, stuff back and forth with a friend, I guess, or maybe a lover. Right. You like that? Throwing him under the bus. And all of a sudden, I guess, when he started to come up on the radar, the Gestapo came in on the network security team, and he was in the same area. Kind of, sure enough, 5 or 6 dudes come in there with somebody from SAIC HR, and they came and told them to leave the area, and they informed us what was happening, and then my boss later told me a little bit more about it. But apparently he was doing that. They came and took his machine, and they kept it overnight, made an image of it, gave it back to him the next day, and on there, the images of bestiality. Yeah, it was something crazy like that. And I mean, they were, I guess, hardcore. I don't even know if you call it porn. I guess we could ask somebody. No, just kidding. But they started to interview the people around them, and I'm every question they were looking at me, I'm like, dude, what are you talking about? Like, I'm just here to develop the system. We got some cool things going on. Pictures, but in order for them to have that no tolerance policy, right? At least SAIC, NASA. I don't think NASA even really cared, because they were pretty liberal with the way that they interpreted things. Maybe he had a pre-existing condition or something. I don't know. But SAIC had a no tolerance policy, and they ended up letting that dude go. But in order for us to conduct the interview, or for them to conduct the interview, you know, there needed to be copies made. There had to be, and you know, the integrity, the reliability of things. There needed to be reports and documentation of each thing that happened along the way. And making an image of the machine here, you can actually create a hash of that hard drive, right, to show that somebody can't deny that, hey, we picked this hard drive up, we immediately made a hash of the hard drive, you know, the image of the hard drive. Because if somebody was to try to, you know, if this guy was to try to go back and refute those charges in court through use of digital forensics, then, you know, who's to say that they didn't alter that information? Well, the hash is proven to show up and hold up in court, and in fact, that's exactly what they did. Is they created a hash of his hard drive. But there's a lot of different investigation types that over the years I've been involved with a few of them. For, you know, different attorneys have come and asked about certain things, especially when it deals with electronic discovery. You know, can we get on people's machines? Can we get on people's devices? You know, what can we do if we get on their devices? And the answer is yes, yes, and yes to all of that. And what can we do? Well, we can pretty much get anything that we want if we have physical control of your device. And so it doesn't really matter what it's for, whether, you know, you have some legal requirements or operational requirements. Maybe somebody's broke the law. We have an obligation ethically as security engineers to make sure that we do the right thing, and it's not always the popular thing to do. One thing to think about here is that a lot of times when you sign that UP for an organization, it says in there typically that they have the right to conduct and monitor anything that you're doing. All that data typically will go into an IDS or an IPS, or it could go into a SIM, right? And that SIM typically is a log aggregator. It's a log. Usually the most prevalent logs that are in a SIM are the syslog. So the system logs and any events that happen on the system get pushed across the network via, you guessed it, DCOM. Here we go, I'm using that word again, right? And the SIM will collect those syslogs over DCOM. Even though it's going over the syslog, I mean, the function of syslog is a DCOM. Continuously monitor people. And one thing that I want to make sure that we are we cover here is this keyword, steganography. And I remember seeing that earlier on in the week, but I didn't cover it then. But I want to make sure I cover it now. Usually in cryptography, this is hidden messages in image, videos, or music or audio files, music or audio files. So it could be in a JPEG, it could be in a MP4, it could be in an MP3. And you're probably like, well, how does that work? Well, it doesn't matter, because to the naked eye, the image still looks like it's a legit image. The video still plays like it's a legit video. The music still, you're able to listen to it like it's a legitimate song or audio file. But what people do is they'll put it in a steganography tool. They'll put the image, the video, or the music in a steganography tool, and that tool will then hide that secret message in the image, the video, or the music file, and then it spits it out, and you're still able to use it. Now, to the naked eye, you wouldn't even know there's a difference in the image, the video, or the music. But if you and I agreed ahead of time, hey, I'm going to be using, I don't know, snow, which is a steganography tool, or camouflage, which is another steganography tool. Then if we know ahead of time that we're both that I'm using over email, image goes through, doesn't get flagged or anything. You get the image in email, you bring it down to your local box, you know it's from me, boom. You can use the same program I did to run the image, the video, or the music through the tool, and then the secret message will come up inside of that tool. It's kind of a clever way to obfuscate or hide use to try to circumvent any type of monitoring activities or any logs. Sometimes people will are clever enough to those messages, they'll steal intellectual property and put it into a steganography message, and it encrypts it so you don't even notice that it's there. So I read an article a little while ago that said that ISIS was using steganography, and the guys from the NSA were able to find that out. Yeah, so somebody says, what about an alternate data path? Yeah, absolutely. Same sort of thing with steganography. Alternate data paths are typically an exploitation of the information. And those alternate data paths are those used to be very prevalent in older versions of the operating systems like Windows XP, but with Windows 7 and Windows 10, I think that those have gone mostly by the wayside. And so, the logging mechanisms can pretty much log any type of data. We can send it to the SIM. See, man, have fun this weekend, huh? They can have any type of data that's sent to them, but you have to configure it, right? And so what does that mean? That means if I have a SIM, so we use, for our customers, we use Microsoft Sentinel as our SIM for our customers because we're a Microsoft Gold partner. And what that does is it takes any data from any of these other systems on those systems, and then it is a log aggregator here. Remember, the SIM is a log aggregator, and it'll munge that information. It'll correlate it, it'll inspect it, it'll do pretty much anything that you ask it to, and it'll alert you. But it's an easy way for you to kind of bring everything together. So with all of that logging, all of that monitoring, we typically will use a number of different approaches. Things that are interesting. And those things that are interesting are going to be things that are outside of the norm, or if we can set rules, right? So for behavioral based, maybe we're looking at what Jen is doing every day, her browsing activities. If she's going out and looking at, Jeep, have cool maps or whatever, and then all of a sudden she starts going to XYZ websites, we might flag that thinking that, hey, that's outside of the normal parameters. And because of that, we may start to watch her. right? We may start to actually turn on a watcher and start collecting a little bit more information about what she's up to. Anything that's signature based is something that we have on file, right? We'll have that on file. About the signature, like a virus or even a bad website could be blacklisted. Those are the things that we usually see in the signature. You have to have it on file though in order to be able to find it. If we don't know what the signature is, how can we have a match to that signature? And then if it falls outside of the other two, the behavior and signature, now it's anomaly based. Outside of normal boundaries. And if it's outside of a normal boundary or standard deviation away from what's normal activities, then we'll go ahead and start to monitor that. But we may do a little bit more additional than just monitor, right? We could then, after that, start to collect additional information. And if we flag that as a start to create a signature on that anomalous event, and it puts us in a position where we can conduct more monitoring activities on that employee. And I say that because, I remember when I worked at a large company, we were in charge of monitoring activities across all of the network. We had a program that was called CIRP, and that was one of the job functions that I would do back then, was look at some of the alerts and configure based off behaviors and whitelist, blacklist sort of thing. And we would block certain things. But if we didn't know that something existed, we would allow people to go out and view it. Well, let me give you an example of that. There was a C-level person at 0800 until 11:30, and from 12:30 to 3:57, let's just say, every day, there would be an enormous amount of bandwidth that he would be hogging up. I shouldn't have said he. So there would be a bunch of bandwidth that this person would be. Much so that, let's just say that my bandwidth, and I'm just going to make something up here. Let's say my bandwidth is 100 megabytes per second, which is kind of high, right? And maybe we have a range that's acceptable, 1 megabyte per second through 100 megabytes per second. So that's the normal user that we'll allow. Okay. Well, this guy would a gig per second, a gigabyte per second. And so, he would come up on the radar for a hog, a bandwidth, and, that for his job role, that was an anomaly for happening. And so what we started to do, we got an alert that said that, hey, this guy is, he's hogging up a bandwidth. Here's the IP, and here's the wall port. Why do I tell you all that stuff? Well, this tells me a specific machine that grabbed an IP, and oh, by the way, this is the room that he's in. And hold on, there's a reason why I'm telling you that. Is because when I started to investigate it, and I looked it up a little bit further, I found out that it was a C-level person, and then I had and double check just to make sure. And sure enough, both of us were able to confirm it. We took it up the food chain to our boss, and then he had both of us go back and double check for a third time, make sure, because we didn't want to be saying anything to Barney Big Dog up top here that could potentially put our jobs in jeopardy. Now he wasn't like the super all the way up, but he was up there. And what it turned out is that we would block, able to block it. And at that time there was this I don't even know if I know how to spell it anymore, but it was called voyeurs-dorm.com. And this voyeurs-dorm.com would actually allow this guy to watch live video of co-eds, we'll just say, this was it's kind of like Big Brother, the show Big Brother, but all these girls were taking off clothes and stuff. And at first, when we saw this bandwidth right here, we looked up the person and we were like, are we sure that this guy is? And so what my boss said is, he said, well, protocol is, this is the policy, right? He signed the acceptable use policy just like everybody else. He said, you have my authorization to throw a watcher on there. We would not just collect the bandwidth consumption, but now we would actually open up the hood a little bit and see exactly what the dude was doing. And so by doing that, we were able to deduce this was the website that he was going to. And so, of course, us being young men, we had to go out to the website and investigate it a little bit further. But it was a paid by subscription website. And so we weren't authorized to pay by subscription. And I had never heard of it before this guy was doing it. And so, next day, we brought it up to our boss. And then our boss went up to his boss. And his boss said that, hey, we need to get HR involved. And so we went and told HR, and HR gave us something else to do, and that was to start collecting information. So this is where it gets awkward right here. Golfer, right? I'm a decent golfer. I'm just telling you that. My boss is a good golfer, or at the time, my boss. He was a good golfer. And so we played in a weekly golf thing for this company that I worked for. On Tuesdays, we would leave at like 3:00 and go hit up the local golf course. And there's probably 30 of us, or 27 of us, I guess, because there was 7 different teams. And this guy was on my team, right? And so my boss was also on my team, and there was one other dude that was on our team as well. And so it was just a chance for us to shoot the stuff and play golf together. Well, it turns out that my boss, he said, well, I think that what I'd like to do here is give him a chance so it doesn't get off this guy to talk to this guy about it, right? And so my boss, I still remember it clear as day. He said, come on, Ben, we're going up. So we walk up all the way to the 9th floor, or we take the elevator up to the 9th floor to see Barney Big Dog up there. And of course, he's our buddy. And we get up there, and usually we're not the top brass, but we came up there and we started shooting the stuff for 5-10 minutes. And then my boss kind of made it awkward. He's like, well, we're just investigating, an event that happened in your office. And, we're network security, and we monitor all networking. Like, my boss didn't have to remind this guy because he knew exactly. I want to remind you that we're network security, so we're monitoring all traffic that comes in and out of the network. We have it all the way down to the wall port, so we know exactly what machine it's coming from and which office it's coming from. And he said, the weirdest thing happened yesterday. Weirdest thing happened. He's like, from your office, we got this right here, you know, and he started telling, he's like, and it looked like somebody was on your computer. And the guy, he didn't have a poker face. Like he didn't have a poker face. You would have thought that, I would have thought that he would have had a poker. Now, in hindsight, you know, this many years later, that being in that position, you probably could play it cool. You know, play cool, man. Just play cool. But he didn't have a poker face, and you could tell that it was him. And he's like, wow, that is odd. That's what he says. He says, wow, that is odd. Huh, I wonder how that happened. And so that I said, did you happen to get up and leave your machine unlocked? Like trying to give him an out. And he said, well, you know, sometimes I am guilty. Sometimes I get up and I don't lock my machine. And so my boss, he's like, oh, you know, we just want to let you know that it is on our radar now that something's coming from this office. And so we're going to be watching with your machine, hint, hint, wink, wink kind of thing, you know. And whether or not that was an exception, I mean, that's over my pay grade at the time. And so I was just doing whatever my boss was telling me. And so, you know, so we still have that watcher on there. And it turned out that for the next week or so, you know, we played golf. But for the next week until like Monday at 0800, nothing happened for the next, you know, 4 or 5 days. And then something on voyerdorm.com must have happened over the weekend, because at 0800 on Monday morning, I guess homeboy must have forgot about it. And sure enough, boom, the event comes up on my radar, and I'm thinking, oh, fuck, here we go. Now I got to go and tell my family, and I'm just like, man, you know, thinking, you know, you get that feeling in your throat. You're just like, oh God. Now we've already given them a warning. HR has already been informed. They have no tolerance for that. So, you know, at that point, we took it up to our boss. The boss is like, all right, well, you know what to do. So we had these virtual files that we would start to create. We'd start to collect log. And so over the period of the next 2 weeks, each day, homeboy every day at 0800 till he went to lunch. And then when he came back from lunch, he'd spin it right back up. He'd log in, and then he'd watch it until he would leave at 3:57, unless we were golfing, and then that would be at 2:57. And each day we were collecting information on it. We would see who logged on the machine. We would see where it was coming from, and the like. And it was awkward because I think we played golf one more time with the guy prior to then. After 2 weeks, my boss took it up to the HR, and then HR had a no tolerance, or I guess they were tolerant a little bit for this guy. But then they said, okay, so they got physical security. They have a security guard come. HR has a box. HR lady, who is the main HR lady, and then my boss, who is the director of IT security, and then me. All three of us walk up there, and the look on that dude's face when we walked in his office, he knew that Judgment Day was coming. Like he was just like, you know, thinking to himself, oh God, I got caught. But I don't understand how or why he would think, hey, this is our job. This is what we do. We're watching you. We're monitoring. I don't understand why he would not think that we would continue to monitor. And so they ended up bringing that box up there, and you know, I stood outside of the room, but the security guard went in with the HR, and me and my boss, we stood outside the room, and sure enough, he came, and it was awkward. It was awkward, but that's what ends. naive folks think that we're not actually doing things on the network for monitoring, when in fact everything is being monitored on the network. So that was one time, and I don't have time to tell you another story, but that has happened at every place that I have worked at. That has something like that has happened, where somebody has been caught doing something that they shouldn't be doing, and it's quite embarrassing if you know the person. Nothing happened while they're being investigated. So I say that because don't be doing stupid stuff at work is, I guess, the first lesson of that, right? But yeah, Amos, yeah, absolutely, it happened on a company computer. And the kicker here, yeah, at work on the company computer. The kicker was, turns out he used a corporate credit card to sign up for that. Yep, that's the kicker. Which I don't blame him. I don't blame him for doing that. All right, so as we're going through and looking at the different operational security concepts, we've talked about a few of these here before, and we're going to just go over them briefly again. There's one here that I think we probably should just have a quick conversation. That's the transitive trust. Transitive trust. That is usually that's kind of tough to explain, but I don't want you to see that on your exam and then be surprised that it was on there. But let's say you have computer A, computer B, and computer C. Right? So transitive trust is kind of like this right here. Well, computer A may have access to computer B, and computer B might have access to computer C. But computer A doesn't have access to computer C. But because computer B has access to computer C, there may be a way that computer A has access to computer C. It could be. And that is how transitive trust, so you're basically you're using a medium to be able to have access to something else. That's usually how that happens. I remember there was one place that I worked that had a development environment. They had a test environment, had a staging environment, and then they had a production environment. And then you as a developer could develop on your local environment. And so what we would do is we could, as the development team, we could develop locally, and then we could actually push code out to the development server with no change control. Like we could do that with no but if we tried to go from our local machine to the test server directly, there was a line of demarcation here that would not allow us to do it. So we were blocked from that, right? Well, it turns out, and we later told them about this, but turns out that the development machine here, let's see if I can draw this here, machine and the staging machine, all three of these machines were just database servers. I'm talking about the databases, and these were all in the same database cluster. And so what we could do here is I could SSH to the development box, and then the test server. So once I was able to ping the test server, let's go ahead and just see what open ports are available from my local machine. So from my local machine, I'd bring up a database management system, and I could port forward from my local machine through the development machine all the way to the test machine to now. As soon as I was able to find that, that was something that I felt prudent to go ahead and bring to their attention. But that's a type of transitive trust because, dev, the development machine, was probably copied to create a test machine, and then test machine was probably copied to create staging machine, and probably the staging machine was probably copied to create. A and B had a relationship, B and C, but A and C did not have a relationship. But because A and B trusted each other and B and C trusted each other, I was able to get all the way over to somewhere I shouldn't have been. Sometimes that happens. Sometimes that happens. And if people don't report it, something like, be able to get that out, but certainly job rotation would be able to flesh that out a little bit more, especially if you were having somebody deploy things out to somewhere, and maybe you were doing something a little bit differently than you were supposed to be doing. Those types of things come into play for bringing that to life. Any questions about that? Yeah, that's right. So in this domain, they spend a lot of time talking about this concept of crime prevention through environmental design. Now, unless you were sleeping the other day when I went through this, I don't think we necessarily need to beat the dead horse in the mouth here, but this is pretty cool. Pretty cool. One of the on the exam is one of the concepts through target hardening is a bollard. So I would definitely know what a bollard is. And I think we covered everything else about CPTPDs. I don't know. One of the things though that you may see on the exam is the use of closed circuit TV, CCTV, or video surveillance. And this has become so much more accessible for us ever before. Usually what people do is they put in CCTV to detect, assess, and or identify intruders. Or if you're like me, I got a Ring, and the Ring will show me any motion outside the front door, including but not limited to when my kids get home, people that are dropping off packages or whatever. So these are different techniques that encourage the operation and maintenance, but really they typically will say that CCTV is a preventative type of control, Why? Why do you think that that is preventative? Yeah, yeah. People know that they're being watched. They may not even attempt to do it. Some people, even though they know they're being watched, still might do it. Cameras set up may give you a 360. Whoops. Excuse me. Come on, bro. May give you a 360-foot view or 360-degree view of the premises if you have the ability or you can afford that. Now, in every movie that we see, there's between there, right? That somebody can kind of slip in between and get between those videos, and somehow they're able to steal the crown jewels or whatever. And that's why typically not only do you have something automated like this and maybe motion detection, but you also have this in conjunction with things like guards or alarm systems or maybe well-lit areas. And so not only is it also other ways that we can detect, assess, and identify intruders. And one of the best things to have is a dog, right? The dog will definitely be able to detect many, many things. And then some of the things that they just start barking because of the fact that they can bark. Make sure we're all aware of here. And one of them is the whitelist and blacklist. What is that? Anybody go ahead and put it into the chat. What do you think a whitelist and blacklist is? Yeah, that's right. Good. Good. So a lot of times we hear the word next generation firewall, or maybe like I was saying, the surf control or a combination of that allows what's accepted in a whitelist, what's not accepted in a blacklist, or what's blocked. And usually that next generation firewall will be in blacklist and any type of policy servers like a group policy, Active Directory, or things like that. Because it is so involved, usually firewalls also have built-in mechanisms that will that you can download from the vendor that will help with protecting different resources. So keep that in mind. What about this guy down here? Honeypot. What is a honeypot? Type that into the chat list there with me if you don't mind. Yeah, the pot is usually a single. Net is multiple. Good. Good. Attracts attackers. Yeah, something to gain. Pseudo network that attacks. Yeah. It's easy to control. Yeah, those are all right. But it can also be a computer or server that's intended to be exploited by attackers. with the administrator's goal to hopefully gain tactics, right? You're trying to figure out in the DMZ or screen subnet of some kind, and it doesn't have access to anything. So no actual internal things. It's for emulation, and a lot of times it looks, it smells, it feels like it's a duck, but in fact it's not. It's just there for trying to gain intelligence on what techniques attackers may use to try to get in to, you know. Let's see here. Talked about backups before. I think we talked about backups the other day in pretty good detail, but I don't know that we talked about a hot site, a cold site. I think briefly I may have, but what's that? Yeah, I remember the for the homework. But a hot site is usually a facility that's rented or leased, and it's fully configured and ready to operate within a few hours. Sometimes you can even part of your available offerings. Now, what do I mean by that? Well, if I am creating let's say I have a web server, what I could do is I could also create another web server and then put a load balancer in front here, and then normal traffic will always goes down, then the load balancer would then redirect it over to the hot site. That is another definition of a hot site. But typically, for purposes of your exam, so usually this is a very expensive option, big money, and usually you lease or rent a fully configured facility, and sometimes all that it's missing is the data to your hot site. So a warm site is also typically a leased or rented facility that usually has some of the equipment. So it's not as, you're not going to be able to get it operational as quick as others, but it's not going to be as expensive as the it usually does not have the actual computer, so you probably will have to bring them in case of an emergency. So that's the difference between a hot site and a warm site. Whereas the cold site is just like the name implies. Usually it is a leased or a rented facility, but I mean, you don't really have anything. You don't really have anything. It's just got the basic supplies. It's kind of like a storage unit, where it's going to be very, very cheap, but you all you have is paperwork there, right? Usually that's what we see for those three options right there. So in business continuity and disaster recovery planning, these come in, and maybe, just maybe, you may need a tertiary site. Usually people refer to these, if you've never heard of these before, as a backup to the backup. So it's the Department of Redundancy Department, right there. Backup to the backup, right? Because all of these would be secondary. The reciprocal agreement reciprocal agreement. This is not as common anymore, but let's say that there's a company, let's call it company A here, and company B here. These companies are geographically dispersed. So usually what that means is that I think it's something like they're greater than 180 miles away from each other. And I would have to look up that actual definition, but far enough away where a disaster over here would not affect the disaster over there. Both of these would be of interest because this one, company A, may give a rack in its data center to company B, and company B may give a rack in its data center to company A. And because of that, they have a reciprocity or reciprocal agreement between the two. That. Anybody ever heard of or done that before? We went over backups, didn't we? All kind of running together now. All running together here. All right, so check it out here. So a non-disaster, these actually do have definitions right here. All right. A non-disaster is a disruption in service that has a significant impact on the conduct of business processes at a facility. So it has a significant but limited impact, okay? A disaster is an event usually that causes facility. Entire facility to be unusable. Here's where it kind of gets gray. For a day or longer, okay? A day or longer. A catastrophe is considered a major disruption. Here's the difference here. That destroys the facility altogether. That's the difference between these right here. The non-disaster disruption in service has significant but limited impact. A disaster, an event that causes an entire unusable, it's supposed to be unusable, for a day or longer. And then a catastrophe major disruption that destroys the facility altogether. So a non-disaster solution could be hardware, software, or file restoration. Disaster usually requires the use of an alternate processing facility and restoration of software and data from off-site copies. And then that alternate site during a disaster must be available to the company until its main facility is repaired and usable. A catastrophe requires both a short-term and long-term solution, and it may require you to rebuild the original facility altogether. I would anticipate that, I didn't say it before, but the hot site, the warm site, the cold site, you're going to see one of those. You're going to probably see one of these on the exam.
Will they get into the weeds about your or understanding what the entity and stuff like that, or is it going to be high level?
Into BCP and DRP, or is it going to be super high level? It'll be really high level. And I'm going to show you here on this slide for business continuity planning. They want you to be able to understand that there is a structured way, have a plan, and implement that plan when you're dealing with business continuity or continuity of operations. And it starts with this project initiation. Then it gets into the business impact analysis. Figuring out how you're going to recover, being able to implement that, and then test it. I think there's another something in here. Let me just see here. Hold on. I think I might have skipped over it. But generally, at a high level, know that at a high level, this is the. So know that this is the process. I want to jump back here for a second. Because with any type of continuity operations, or if you jump into the disaster recovery plans, there's going to be some different types to make sure that we're following the proper components. And so these three types of tests are usually one of these will show up on your exam. Usually one of these will show up on your exam. So hold on a second. This is getting hot. Taking off here. All right, so the first one here, sometimes you'll hear it called a read through. It could also be called a checklist test or a desk check test. Is you distribute the plan out to the different departments for review, with the intent that you say, hey, I'm going to put a time limit. You got to get this back to me. Any changes got to get back to me next Friday or something like that. And what that does is it gives the functional manager a way to indicate if anything's been left out, or if okay. So the structured walkthrough test, usually representatives from each department will come together and go over the plan for a chance to ensure its accuracy. So usually this is an actual test, really a meeting where you will review the plan and basically discuss it. Like you'll go through each person, each functional department, and you'll come up and discuss and review it. But it's not actually So the drill actual disaster to portray a more realistic environment. Usually you'll try to identify if any steps are left out here, all the while trying to get into the simulation test here, right? That's where you're trying to go. So this one takes a lot more planning and a lot more people. Employees who participate need to come together and actually practice what's going on. So they practice executing the plan. They practice the execution of the plan. Make sure that things weren't overlooked. Usually it tests up until the point where you relocation. So you pretend in this particular case, and it's something that you usually will do. This is typically done semi-annually, at least in my experience. There's a lot more rigor put on disaster recovery plans on the financial. Because if they're trading stocks and if something happens, then that's a big deal. So another one that you may be interested in, here it is right here. Full interruption test and a parallel test. So the parallel test, you actually will, let me use a different color here. You'll actually use you'll take some systems, so you'll move some systems to an alternate site. And you'll run through test. Now, you don't want to do all systems here. Usually, let's say you have, I'm just going to make up a number here. Let's say I have 8 different systems, right? What I'm going to probably do if I'm in charge of this, which is I'm going to probably do 8 different parallel tests. at first, right? I'm going to go through. We're going to move the first one over to the offsite. Then we're going to move the second one only, right? So the first one will come back, the second one only, then only the third one, then only the fourth one. So we're going to do 8 of these types of tests. So we'll do 8 tests, and these may be, you know, if we're aggressive, every other month. 2 at a time, right? And constantly practicing this type of test. Then maybe once we get good at it, after a while, we'll do 4 at a time. And as we gain more budget, we may actually leave these. A lot of times nowadays, these tests are using cloud services even more so, because it's much more cost effective to be able to provision a cloud asset and then basically you point DNS to that cloud asset. A lot of times you'll see people anybody ever been involved with a disaster recovery plan? Excuse me, disaster recovery plan? If not, then okay, good. Yeah, then you probably are, or actually you have the experience here. Because you may go through basic life support training, maybe like an active shooter training, you know, so you can become more aware of what to do if there is an issue. This one, the full interruption test, this is the most intrusive. And this takes quite a bit of planning, Usually, at least in the financial world, in my experience, usually over a weekend. And usually it's an off-site facility where you basically shut down operations at the primary site over the weekend, and you move everything to an off-site. But you know, all of these different tests, the most important thing, like you asked what's important about BCP and DRP, I'd say backups, the types of tests. This is, to me, maintaining the plan and exercise. Like if you don't exercise the plan, then it's only as good as the last exercise that you do. Tom Brady came out with a quote the other day. I'm a football fan. He came out with a quote the other day that said, "Hey, I'm only as good as my last time that I played." They still have him try to prove himself at 42 or 43, right? So it's all about what have you done for me lately, especially when you're trying to keep the continuity of operations intact. So I would say, you know, those things that I said. In addition to that, one last thing here is RAID. You will see a question on your exam on RAID as well. Anybody have any exposure? Okay, good. You know, I don't want to just jump over things in the interest of time here. So if you guys got to dip out here at 4 o'clock, then I understand. But I want to make sure that I cover as much as I possibly can for you. Okay. So don't get angry with me. If you got to use the boys' room, go ahead and use the boys' room. So one thing that may show up on your exam, may is a key word here, right? Is some of these terms right here. And I guess if you've lived in California, you may be more familiar with these than other people. But they have them classified as these different and power degradation. And in this operational security domain, this is where these fit in here. Okay. So I would probably, if I was you, spend a little bit of time going through these. I mean, I can review these, but I would say that there's probably going to be one of these right here on your exam. So there'll be, well, let me change color. There'll probably be one of these, one. So if you're not familiar with these, the book does a pretty good job at going through and talking about these, and usually the one that we see on the exam is a surge. Usually that's the one that we see on the exam. And the surge is a prolonged rise in voltage from a power source. Usually that's why we have surge protectors, is to try to avoid our machines getting fried. It has metal around when surge occurs, and it protects accordingly. One other thing that you may see on the exam here are methods of fire suppression. Has anybody ever, do we have any volunteer firefighters on the line? I've had volunteer firefighters. Anybody? No? Okay. There we go, Amos. Good. I mean, you're a man of many talents, aren't you? All right, so check it out. I'm going to give you the straight dope here, because if you're probably like me, you're just like, wow, man, this is a lot to remember. Do this. Well, you're in luck, because in your book they actually outline this, and you can spend some time looking up the fire suppression methods. But I have an easy way that I typically will remember this right here. And I'm going to show you right. Oh my God, there's a lot of. All right, there it is. So in here, they go through and identify they actually take the 4 types of suppression methods. They identify the different types of suppression methods here. And then the way that I remember this right here, and you can use whatever way you want. And if somebody else has another way to do it, I'm all ears. But usually the way that I remember this, and I can't keep both of these up at the same time. Okay, well, I can write on this, I think. Yeah. So I remember class A. I remember ash, wood, paper products, and laminates. They turn to ash. And we can put those out with water and foam. Right? So liquids, will flow to the basement. So liquids like petroleum products and coolants, pretty much you're in trouble. You got that type of fire, right? But you can put it out with gas, CO2, foam, dry powders. So there you go. Class C fires, I think of a computer. A computer has electrical components in it. So electrical equipment and wires. You got bigger problems to deal with. Hopefully you call the fire department for that. But gas, to make magic happen there. And then over here, D, Class D, things that dent or metals dent. And you're in big trouble if you got magnesium, sodium, and potassium in your fire. You got bigger problems. But dry powder, I actually saw a blanket recently somewhere that they put over a car. Yeah. And then finally here, K is probably the one that everybody knows. That's a kitchen fire. Or I think of kitchen, and that's usually a grease fire. Grease fire. And you definitely don't want to throw flour on it to put it out. So I would definitely call the fire department. I know we have a fire extinguisher underneath my sink, and I think that it puts out grease fires, but yeah, I think it is foam. I was going to say foam. But yeah, you're in trouble if you got a grease fire. So try to put it out as quickly as possible. But floor burns. Flower burns. Oh, flower burns. Yeah. Flower burns. Yep. Types of things that we typically will see. All right. Any questions on that domain before we jump into the last one here? All right, before I start losing people, because I'm sure that there's going to be some folks that are just like, yo, I've had enough. Before I start losing people, I'm going to do this when we're going to have a review. And then if you can make it, that'd be fine. Instead of me saying, when can you make it? That's the way we're going to roll. Is I'm going to give you my calendar for next week, and I hope that you can make it. All right, so I think what I'd like to do is next Friday from 2 to 4. Oh, Friday the 13th. Next Friday from 2 to 4, right here in the facility. I'll also open it up to the WebEx if you can't make it. So 2 to 4 next Friday, we'll do a review. So that's the 13th. Okay. And then the following Friday, which is the 20th, from 2 to 4. So those are going to be, I'll give you 4 more hours of my time. There is a cost associated here, but it's more of a intellectual property cost, right? The cost of entrance here, whether you come to the WebEx or you come in person, is you must have 10 items that you want to review. Okay, that's the only thing I'm going to charge you, is the 10 items for review. So I feel personally that if you have a week to see if you can sharpshoot me, that's plenty of time to see if you can stump the panel. And if you can stump the panel, I'll challenge you here. If you can stump me, and well, you guys, a couple of you guys already got shirts, so I'll give you a free coffee mug. You know, if you can stump me, we'll have a nice door prize for you. How about that? We'll figure something out on either one of those days. So I hope that you can attend either the 13th from 2 to 4 or the 20th from 2 to 4. And typically, I don't have saying that there's 9 people that are on this WebEx right now, okay, including the 2 that are here in person. I'm just going to tell you. I open that up because usually when I offer it up, usually I only get 1 or 2 people that show up for the review. So I hope that you come to the review, but I don't care if you come to the review. Or in person, I'd love to see you, but you know, it's up to you. If you want to pass this exam, hopefully you can, the next week or so, maybe the next 2 weeks, you can, you know, at least look at this stuff for 2-3 hours a day, start taking more practice tests. I'm going to share some resources with you, some additional resources that I'll share with you that will be even more so helpful. But the Cyber Ninja, it has plenty of test questions on that. Done. Has anybody looked at when the test is available? Oh shit! January.
The closest location that's got stuff within the next 2-3 weeks.
Oh, okay, that's not that far.
There was some in Birmingham, sporadic, 2 below.
Okay. That sucks. Although, you know, that can either be a great ride home or a very bad ride home, right? So we had some folks here checking in person saying that the one in Decatur, and I think that they have limited. The one in Decatur looks like it's unavailable. So keep that in mind. If you haven't received your voucher yet, I know that she ordered them, and I think that we got them, but I'll double check with her. I'll double check with Melissa. I don't know. Did anybody get an email from her? Okay, so we should have the vouchers, and I'll make sure that we get those to you just as quickly as we possibly can. So usually, sure we get those to you. All right. So the last domain here, now that I've given you the times that we can meet, or the times that I'll meet, is this network security and communications. So this is a massive domain in the book. Massive domain in the book. Okay? But could spend an entire semester on this one domain, like going through how the internet evolved, what kind of cabling is there, you know, the whole everything involved with networking and communications. We could spend a long time talking about that. But I don't know if that would help you pass your exam. And typically, what I like to do is give people the straight dope on what they can expect in the networking and communications. You definitely will have at least one question on the OSI model and this other thing that's called the TCP/IP model, which we're going to talk about here in a second. If I was willing to bet a paycheck, I would say that you will have a question more than likely either on something or something in layer 2. Right? You probably will have something in there in layer 2 or layer 3. So keep that in mind when you're going through and doing a little bit more studying about each one of them. We've talked about encapsulation. Right? And we've talked about decap. Ways to remember this. And, I think hopefully it makes sense. I think I even drew this out one time. That essentially, depends on if you're going down the stack or up the stack, how this works, where it'll get appended, the data will get appended with each layer as it's going down the stack. Each layer will add on a little bit of a love here, a little as it's going down, and then it'll strip it as it's moving up to something that we can actually view in the application layer. Right? So again, I'm gonna tell you that you either know this or you don't. On the OSI model, usually you will have one question. Now, that question it'll give you a context clue. It'll say the network layer, let's say, I'm just making something up here, right? In the network layer, or it possibly could say layer 3, in the question. It may give you a scenario, but it kind of gives you that context clue of what's going on there. So keep that in mind as you're going through and preparing that. You may have one question on that. You probably had done it for homework last night. You probably will have a drag and drop on, it'll give you 7 landing spots on one side, and then 7 drag and drops over here. This will be worth 1 point. It's supposed to be 7. Sorry, guys. And then you drag the appropriate layer into the appropriate thing, and pick the order that it wants it, because it may give you a context clue of decapsulation. Right? So we know that it goes in which layer comes first in decapsulation. Right. So it would go from 1 to 7 if they give you that as a context clue. Right. So don't miss that keyword, because I would hate for you. I mean, you either know this or you don't, but I would hate for you to know it and then something silly like that where they okay. And so this TCP/IP stack is an alternative to the OSI model. Okay. And usually what people say is there are the 4 layers. There's the application layer, the transport layer, the internet layer, and the link layer. It looks at it one way, and you may be thinking to yourself, okay, what is the straight dope? Well, let me show you here. There's some really good examples here. And this is one that I like. Let me bring it up. So if we were to take a look here at these, OSI is on this side over here, and TCP/IP is on this side over here. You can see that the application over here has these three that are associated. Transport goes to transport, network goes to network. Sometimes you hear people say these a little bit differently, like the keywords. For the purposes of the exam, what I have over here, these words that we see here are typically what we see on the exam. But if you know the application layer goes to the 3 application, presentation, and session layer of the OSI model, transport goes to transport, the internet, well, that's the network, goes to network, right? And then the link or the network interface. I actually like that word a little bit better, network interface, because that's really, this right here is the MAC of the data link and the actual physical connector. So like a Cat5 cable for here, or wireless. But usually we see it labeled like this over on the right-hand side that I'm showing over here. In business, I personally, in the 20+ years I've been doing it, in business, in practice, I've never heard anybody say, "Oh yeah, in the TCP/IP model, layer 4 of the TCP/IP." I've never heard anybody say that. Usually, people reference the OSI model. For purposes of your test, I wouldn't overlook that. I doubt that there's going to be a question on there on the TCP/IP model, but I don't want to overlook it and tell you that it's not going to be on there. Okay. Doing the same thing as the OSI model, but it's because TCP is very widely used. TCP is a connection oriented, right? It makes a connection. That connection is typically referred to as a socket once it actually makes that connection. Usually, when we're talking TCP, it has the 3-way handshake. Right? That 3-way handshake is a SYN. So we have computer A over here, computer B over here. Computer A wants to communicate with computer B. It's going to send a SYN across. Right? Computer B will send a SYN ACK across, and then computer A will acknowledge and complete the connection. Typically, that'd be nice if you saw a question on the 3-way handshake. Usually, you'll see a question on the attack of the 3-way handshake, like something like a SYN flood. And I think Jen and I, we had a classical conversation the other day where she did a denial of service on me, and I was just attacking you with the SYN flood attack, I believe, right? Just like you'll never, next time you see him, you're going to be like, you know what, that dude's cool, even what everybody else says about him, just because we got the same birthday. I mean, we're attached to the hip now, right? All right, so in this domain, they spend probably 50 or 60 pages, probably, going over, and it's a long read, but it's a good read. If you don't understand reading this domain, and in my studies, if I was you, if you're like, man, shit, there's so much stuff, man, where do I start with all this stuff? Because it's not making sense. If I was you and everything that I'm saying right now on the technical side of the house, not to be confused with the more managerial stuff that we've gone through, because you either are this exam. So if you understand the technical stuff, this is easy peasy lemon squeezy for you. You would have to spend more time on the manager side, right? If you understand the management side, but not as much the technical, or it's been a while for you since you've done the technical, I would start with this domain. I would read this domain first in my preparation, because it'll go through and tell you how every one of these things work. It tells you how every one of these things work, and more importantly, what say anything about TCP/IP model, like what layer of TCP/IP model is, because it's inferred that the top three of the OSI go into the the first layer, or the top one of the TCP/IP. And so what I don't want to do is I don't want to go through and talk about each one of these in great detail. Usually the way I kind of look at it is, this is what humans typically can see. Like, this is what the normal user will typically never come out of, is the app layer, the application layer. And so a lot of things that they'll use in this layer, probably the primary one that is used in this layer is this one right here. Right? Everybody uses a browser to get to the internet. So that's what I would. So the presentation layer is, for me, how to format the data. Right? It can be in any of these different formats. Makes no difference. It depends on, obviously it depends on what app you're using and how it allows you to present that data. A lot of modern day apps, if you choose to save as, you can save it into any format or any presentation. Like, how do we want to present that data? It is one of the more difficult ones to try to explain, because really it's making a connection. That's the easiest way for me to explain it. It makes a connection. Usually, if you're going to get a question on something from the session layer, NetBIOS is probably the most popular that is used. Okay. The second most popular would be so let me just write a number one right here. Number two would be making a remote procedure call. So, you have one computer, kind of like it's almost like a DCOM, right, that I mentioned earlier. You have computer A, computer B, and computer A needs to get something off of computer B. So it calls computer B, and computer B either allows, and that's a remote procedure call. Certainly, all of the other things usually will fall within one of those two, right? It'll fall within NetBIOS or remote procedure call. This is a remote procedure call, NFS, and SQL is a remote procedure call as well. Okay. So the transport layer, TCP or UDP, okay, at this layer. We'll talk about those here in a second. We've mentioned before, TCP is connection oriented and UDP is connectionless. A lot of times you hear people, and I mentioned this the other day when we were talking, I think, about streaming or with Alicia, now that I recall. Sorry, Alicia. And I think it was probably happened to me this morning. But it's a fire and forget. And I have to do it. A lot of times people, when they're explaining UDP, will clap their two hands together and kind of fire and forget, where, it kind of queue up. it doesn't make a connection. It can queue up, and then it will try to catch up, and you may end up missing some stuff because of it, like audio or video. So anytime that something ends with an X, or in the next one, I think we'll talk a little bit about it, IPX. Ain't nobody using Novell anymore. Come on, let's just be honest. Novell tried to create its own, like Lotus Notes. You may have heard of Lotus Notes before. They tried to create their own secret package exchange and internet package exchange, and it didn't flow because nobody was really using it. Everybody started using Microsoft. SSL runs at the transport layer. Let's keep going. The network layer, to me, and the data link layer, these two are probably where people spend the most amount of time. So, this is oftentimes how, IP is explained to people is mailing address at your house. And how does it get from one place to another? Well, we got to be able to have a place to deliver it. And that's kind of like your mailing address. ICMP, to me, every time I see that, I think of one thing and one thing only. What do you guys think of? That's what I think of. The ping command. ICMP, which we do in the CEH, there's actually like 12 different things that it does, but for purposes of your exam, ICMP is used for troubleshooting. We're running a Security Plus class right now in the evenings, and out of those, however many students we have, I'd say 90% of them didn't know what ping was. I don't really remember what IGMP is off the top of my head, and hopefully you allow me a pass on that. I think we went over OSPF. I think we did. Talked about algorithm development. The routing information protocol is used here. I believe that out of these two, though, this is OSPF by default, because I don't remember off the top of my head. It's been a while since I've read into that. Why, other than just for sheer performance and dynamic routing. But I used to know that. The routing information protocol. Data link layer. Let me make sure that we're on the same page. So I think I mentioned before, but I'll say it again here, that typically routers, and I don't want to get confusing with my semantics here, but routers will, they'll actually switch data. That's going to be the word that I'm going to use. Routers will actually switch data from one place to another at the network layer. But switches deal with MAC addresses, and usually they will operate over here at the data link layer. Okay, so routers deal with IP addresses, switches deal with MAC addresses. All right. Hopefully we got people still listening online. Go ahead and put in the difference between ARP I'll give you a hint. Both of them translate. ARP translates and I would just make a note card and memorize that if I was you. Okay? Good. Yes. Good. I just put it into the chat. So I have the IP and I'm looking for the MAC. So I say ARP. I send out the IP. The network has the MAC address. It'll say ARP. Send back the MAC address. Maybe not like I just did. But that'd be kind of cool if it did, right? Maybe we can get OK Google to do that for me. So reverse ARP or RARP, and you're looking for the IP. So if you don't know this, I would make a note card. There will be one question, and it'll be either one or the other, ARP or RARP. While I'm on this right here, I know we're getting to the witching hour here. It's probably going to be dark. Yes. I'll put those videos. I'll make sure all the videos are up there this weekend. I'll make sure 100%. See you, man. So one thing that I want to make sure here, this concept that you may see on the exam, that's called ARP poisoning. And ARP poisoning will, just like the word infers here, it'll poison the ARP table on a router. So if you're able to poison the ARP table, IPs and MAC address link, right? So if you call a router and you ARP to a router, you're sending the IP, you're asking the router, hey, give me the MAC. Well, if you're able to poison that router and update that information, ARP poisoning would come into play, and that allows you to, you can redirect traffic computer. So attackers will try to do ARP poisoning. Typically, ARP poisoning is on an internal network, whereas DNS is very similar. DNS poisoning means you're able to poison a DNS table somewhere, and that's usually on the internet, right? So DNS poisoning is on the internet. Very rarely have we seen any types of attacks with DNS poisoning on a company's DNS server. Usually it's like a main DNS poison that happens. Like I think Apple had that happen over in the Philippines or Malaysia about 3 or 4 years ago. All right, and then the physical layers. This is wireless. All right, let's keep on going here. Thank you for your patience. So TCP and IP, again, this is the connection-oriented. Right? You make a connection. This sends and receives acknowledgments. And more importantly, it ensures that data okay? Whereas we talked before about a SYN, SYNAC, and ACK. Say that real fast a bunch of times in a row. That's the three-way handshake. That's three-way handshake. So connection-oriented, and you set up a handshake, and it ensures that things. If not, it'll send back a response and tell you, hey, we weren't able to do it. UDP is a connectionless. We already talked a little bit about this, right? Connectionless oriented protocol. And it does not send or receive acknowledgments. So it's beautiful for pumping large amounts of data, because then you don't have to negotiate connections. You don't have to, do anything along those lines. It does what's called, and I know this is kind of funny here, as funny as dorks can be. It makes a best effort, but it does not ensure that the data arrives at the destination. Again, it does not ensure data arrives. Okay, so connectionless, best effort. One thing to note here. Oh, hold on. Usually we call it with TCP. Usually we call these packets. With UDP, usually we call this datagrams. Now, I would absolutely let you get away with calling it packets, but I mean, technically it's called a datagram. Thing that we've gone over so far. All right, here's just a list of things that go over typically. UDP, right? Media, streaming media is probably the biggest one. I read something the other day that said that Netflix was responsible for and that last year alone, the traffic on the internet was greater than the last 30 years. Last year. Isn't that interesting? Maybe it's not. Which is kind of, I thought it was kind of neat. So there is something that we need to make sure that we talk about here, and that is the different types of switching. Okay, check it out. So when we talk about how things are switched, how does something get from one place to another? There's either switching. With the circuit switch, I think about, 100 years ago, that a lot of times there would be people in a room that, they would have these plugs, and the plugs would, these cables, they would take one cable, they'd physically take it out and then pop it into another one. Like they would answer the phone, hello. They take it out and they physically put it in there. So how does that metaphor work here? Well, it's a dedicated circuit. So it's a transparent path between you and the other place. So really you open it up, and then it really becomes a circuit between you and the other person or the other place. With is between that two. Okay, so dedicated circuit. Whereas a packet switched environment in network switching is typically blocked, like packets are broken up into blocked. Packets are broken up into blocks, and usually they have and that sequence number, if I'm company A over here and I want to do packet switching over to company B, if I start and I'm using packet switching here, let's say I have a big chunk of data here. What I'll do is I'll break this up and assign sequence numbers. I'll go ahead and send all of them out to the internet. I'll send them out 1, 2, 3, 4. I'll send them out in order. Well, it may bounce around the internet, and down here you may actually receive 4, 1, 3, 2. And what it does is with packet switching, you send it out in a segmented or blocked buffer, and then it's recombined. So I send it out in an order. It goes out on the internet, and it assigns these sequence numbers to make sure that when it's put back on, or whenever it's pushed to the other line, the sequence to reorder it. And that's typically why we see some of those with sequence numbers. Like if you look at packets, you can actually look at it and there's a sequence number on there, and then that's how dynamically they can be ordered on receiving it. We went through some network addressing and the different octet. I'm not going to go through this again, but I would tell you that I would just know the different classes if I were you. Really for Class A, it's they say 128 Class A domains, and this is the number of hosts that you get on there. Anything 100 is considered a Class A address. Remember, 127.0.0.1 is the local host or the loopback address. So that's reserved, 127.0.0.1. Class B typically goes from 128 to 191 in the first octet. That's immediately how you can see if it's a Class B address. Class C goes from 192 to 223. And I think I brought up the other day in my California Highway Patrol, the CHIPS, you recall, the broadcast here, the host address of all ones. Well, if I have 192.168.1 dot, if all the octets binary here are all turned on for the bits in that octet, the total value is all ones, and that equals 255. So the broadcast address on any network typically will be 255. So a host address of all ones is a broadcast address, and that'll be 255. The 0 here is reserved for the wire itself. So if I'm doing 192.168, that's not a valid IP address, so I can't use it. It's reserved. Usually when you see this right here, there will be CIDR notation involved. And if you recall, that would be something like 192.168.1.0 and then / it would give you the subnet mask after it. And that 24, remember, 1, 2, 3, 4, 5, 6, 7, 8, boom. 1, 2, 3, 4, 6, 7, 24, right? 8 is 24. So my subnet address in CIDR notation is / 24. But I know that that is all the ones, 255, 255, 255.0. And the other one I would throw in here, the other one that's reserved, like I just said, there's no place like home. And somebody had a shirt that said there's no place like 127.0.0.1. I was like, I know what that means. I know what that means. Yeah, I'm a dork. I actually laughed because I'd never seen that before. So IP version 6 goes and pushes it up to 128 bits. I'd be surprised if you saw any questions on IP version 6 on your exam. But feel free to come on back with any questions. They created IP version 6 because we thought that we were running out of IP version 4 addresses. And so now typically you'll get assigned an IP version 4 and an IP version 6 with all of your IP config with modern day server environments. At a very high level, I would know at a very high level, and we went over that the other day. And this is it right here. It defines which portion of the 32 bits represents the subnet mask. Remember, the CIDR notation, the classless interdomain routing. Sometimes you'll see a question about secure socket layer on your exam. Typically, this is the default that we use for web-based applications to go over HTTPS. It runs on port 443, but it's SSL version 3.1 actually uses TLS 1. Something. I'm not sure which one now, but it actually is using behind the scenes TLS now, that type of encryption. These other two we usually don't see on the exam, the SHTTP and the SET. We usually don't see those on the exam. Some that maybe not an easy question like NAT, but this one might be embedded in a question, right? Like it implies that you already know what NAT is. And the internal address is unreachable from the external. Remember, it's just a translation from public to private IP. Good chance you're going to see something about a DMZ and something about an access control list. ACA that are associated with firewalls and typically rule-based access control. Typically, they're logic-driven. So if, then, else. A DMZ is where you typically want them to be reachable from an untrusted network like the internet. So in the DMZ, you might put your website. Or you might put what's called a bastion host. And a bastion host typically is a server that has only running on it. And it has with no connections to the internal network. Internal network. Easy way for me to remember this right here is this bastion host, which you may see that term on the exam. I think about, and forgive me, because this is how this is. Sounds like the word bastard, and it's put out there by itself with only one thing running on it. So it's left out there alone. It's kind of like a bastard. It's left out there alone with only one service running on it. Oh, there it is right there. This just means that it has usually 2 or more NICs or network interface card, where, if you have, let's say you have 2 NICs, maybe, traffic is ingressing and you send it over to a network A over on this side. And then maybe you also mirror it to go over. But you could also have, a number of different things that you can configure with the dual homed firewall. That's a discussion for a different day. Usually one thing that you do see on the exam is the DMZ, like I said. It might be referred to as a DMZ or this thing that's called a screened subnet. Just like I just said, you put that dirty bastard out there by itself running one service. That bastion host is out there maybe running something that you want to offer up. And that can be a number of different things. I'd be remiss to not talk about VPNs. To leave here not talking about VPNs. If you're not familiar with what a VPN, there's a number of different types of VPNs. One is a PPTP. Kind of a funny way to say it, right? Typically a PPTP will be on a Microsoft remote access server or a RAS server. This doesn't necessarily have to be for dial-up. It can be a VPN for not over a phone line, but I think that was when we were creating these slides, that's what we meant. For users to access a company's intranet. Usually there's some sort of two-factor authentication here, like an RSA secure ID, key fob. And that key fob typically has 6 characters on it, and it is temporal. Where in order to access the PPTP and the VPN, you not only have to have a password, but, so this is something you know, right? You also have to put whatever that temporal token, something you have right here, that temporal token, on the tail end of your password. So, you know, if your password is PAT_SSW0RD, you got bigger problems. But then you want to put, that's how you would be authenticated. Now, it uses, typically, this PPTP will use something like a CHAP or an MS CHAP protocol, which is a challenge handshake authentication protocol. And that's what I just drew up here, where we're challenging you to give us something more than and authenticate after you've given us that secure ID. SSH is how I do a lot of things. You know, that runs over port 22. And in addition to that, you can do SFTP, you can do SCP through it, secure copy or secure file transfer protocol. It absolutely can be used as a VPN. Can be used as a VPN. And with SSH, you can also do, usually we see SSH on Linux boxes. All right, so I think the last thing that I'm going to talk about here, because it's getting close to me needing to let you go, is this IPsec. And IPsec is kind of cool if you've never seen this before. It actually is the de facto implement any VPN. It actually, let's say you want to go from A to B, what it'll do is it'll create a tunnel in between you and the destination that you're trying to get to. So it'll do that in a number of different ways. These two that we see here are the two modes that it operates in. The transport mode encrypts only the data that's being sent. The header is sent in clear text, and that's done for performance. So if there's a lot of people using a VPN, like especially during COVID, you may be using only the encrypted payload and sending the clear text header for performance. Like, you know, let's say you have 100,000 people. Otherwise, you're where both the header information, where it's going, where it came from, source and destination, and the payload are encrypted. So this is everything. It's a little bit of a hit, but you know, if your company, let's say you have 1,000 people or 10,000 people that are running off a VPN using IPsec, you shouldn't see anything as far as performance degradation is concerned. If you got 100,000 people that are using the VPN, one and another 50,000 on another, because this is the preferred method to use. Tunneling mode is the preferred method to use. All right, so any questions about anything that we've done throughout the week? Just turned 5 o'clock. You got a lot?
Ben, I've enjoyed it.
Okay, well, thank you. I'm glad you enjoyed it. So I am free to the questions.